This is a recursive sequence, and it's very, very simple, even though a lot of you are scared off by this at first. So we start off with the first term in the sequence, which clearly they give us, and it's 1. So the first term is A1 equals 3, so 3 is the first term. And then what does it tell us to do? Well, it tells us to take that first term and add 4 to it. So what's the next term in the sequence? Correct, it's 7, and then it's 11, and then it's 15, and so on. And you should very simply be able to find the nth term from there. So I would simply look at the difference, and you can see that the difference is going up by 4 each time. Alright. Well, since the difference is 4, then I know it's going to be 4n. Now 4n doesn't get us to the right place. This is the first term, so 4 times 1 is not 3, so we have to subtract 2. Let's just check that. So here's the second term. If I plug in 4 times 2 minus 1, I think that works, doesn't it? And here's the third term, so let's just check, does 4 times 3 minus 1 work? Yeah. So the nth term is a sub n equals 4n minus 1. The next problem is going to ask us to use binomial theorem, something like this. How about 2y plus 4x, and let's do that to the 6th power. So off to the side, I'm going to draw up Pascal's triangle, because this is the easiest way and the quickest way to do it. So if you remember, it looks something like this, and we just added the terms above. So then we got 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5. Let's make sure I don't make any mistakes here. Hope you can see how I'm building this triangle. It should jolt your memory from class. Have I got enough? 1, 2, 3, 4, 5, 6, 7. Now you'll notice this number here is the 6th power, and because it's a 6th power, we need one more line in our Pascal's triangle. You notice here we've got 7 terms. So in the expansion to the 6th power, we're going to have 7 terms. And the first thing I'm going to do is I'm going to take these numbers right here, and I'm going to write them out with the big space in between. So let's go 1, 6, 15, 20, 15, 6, and 1. I'm going to now get this out of the way, because space is definitely at a premium here. Okay, next up. So now we're going to take this right here, and we're going to do powers of that. And we start on the left, and we say, okay, so now we have 2y, and that's to the 6th power. That's basically the same power as this right here. And we do the same thing all the way along. We just go down by 1 each time. So 5th power, 2y to the 4th power, 2y, 3rd, 2y, 6, 5, 4, 3, 2y squared, 2y to the 1st, and then that's it. And then we do the same with this one. And again, I'm going to change colour so you can try and see what's happening. So now we do 4x to the 6th power, so we start from the right side. 4x to the 5th power. I should try and zoom in a bit because it's getting really, really tight, isn't it? 4x to the 4th power, 4x to the 3rd power, and so on. And there's going to be a plus in between each one of these. So a big plus, 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 plus. Okay. Got to be super careful now. Let's just attack these one at a time. So I'm just going to zoom in here. I want you to see what's going on. A lot of you, for this first one here, are going to say, oh, that is 1 times 2y to the 6th. And you would be wrong. The reason you'd be wrong is because it's the whole thing to the 6th power. In other words, this 2 needs to be 2 to the 6th power. So it's 2 times 2 times 2 times 2 times 2 times 2. What is that? Well, that is 64y to the 6th plus. Now let's focus on this. Well, that is 6 in red times 2 to the 5th, which is 32, times y to the 5th times 4 times x plus 15 in the red, we're now working on this one, times 2 to the 4th, which is 16, times y to the 4th, times 4 squared, which is 16 again, and then that's x squared, plus 20 in red, and then 2 cubed is 8, not 6. Gosh, I wonder how many people are going to put that. 4 cubed, 4 times 4 is 16 times 4, 64, x cubed plus 15 times 2 squared, 4, times 4 to the 4th. Well, I'm going to need a calculator for that. That's 256 x to the 4th, and then the final one, oh no, it's not the final one, is it? Good grief, this goes on forever. Plus 6 times 2y times 4 to the 5th, which is 1024x to the 5th, plus 4 to the 6th, good grief, which is 4096x to the 6th. And that's not finished, but let's just kind of scroll back to the beginning of this. We'd have to multiply each one of these terms. So the first one, that's okay, 64y to the 6th. But this one right here, I think we can do better by simplifying that. So 6 times 32 times 4, that would give us 768 y to the 5th x, and then we go on to this next term here, but I'm going to let you finish this problem on your own. What about if you're asked to find the inclination of a line given 2 points? So let's pick 2 points. Let's say 1, 7, and a second point of 4, -2. So inclination is very different from slope, but first of all let's find slope. We know the slope formula is y2 minus y1 over x2 minus x1. So when we plug in those points, we're going to get -2 minus 7 over 4 minus 1, which is -9 over 3, which is the same as -3. So our slope is -3. Now, looking at our formula here, we see the inclination of a line is m equals tangent theta. We've just said that our m is -3, so we can say -3 equals tangent theta. Since that's a negative slope, if I drew a little picture of this, it might look something like that. That's a negative slope, isn't it? And when we find our theta, well, in this case, this is our angle right here. Okay, so let's just plug in tangent inverse of 3 in the calculator, or of -3, and see what we get. So tangent inverse of -3, and I'm getting -71.6 degrees. So this angle right here, don't worry about this negative, but basically that angle right there is 71 degrees. And inclination is actually this angle on this right side. So to get that, we're just going to do 180 minus the positive of this angle. So 180 minus 71. So that will give us 108.4 degrees. Could you find the center and the vertices of the given hyperbola? So they're giving us a clue as to what this looks like. It's one of these. It's either that or this one. Don't know yet, but we'll soon figure it out. So we're going to have to do some completing the square here. So I'm going to start by getting my x's together. So 9x squared minus 36x. Then I'm going to get my minus y squared minus 6y. And I stick the 18 on the other side. Now to complete the square, we can't have a coefficient by these squared terms. So I'm going to factor out a 9. And that's going to leave me with x squared minus 4x. I'm going to close the parentheses there and then do another one for the y, except I'm going to factor out minus 1, and that's going to become y squared plus 6y. Close the parentheses. And now we need to add a fake term, and it all comes from this number right here. If you recall, we divide by 2 and square it. So 4 divided by 2 is 2, squared is 4, so we're adding 4. Some of you at this point are going to be tempted to add 4 over here to keep it balanced. But be careful. We're not actually adding 4 here, we're adding 4 times 9, aren't we? So 4 times 9 is 36, so let's add 36 here. Now let's do the same for this term here. Divide by 2, we get 3, and squared we get 9. And then that 9 is times by this negative 1. So we're actually subtracting 9, which means we subtract 9 from the other side of the equation. Now we can complete the square, so this is going to become 9 times x minus 2. That's the rule. You basically do half of this term. Minus y plus 3 squared. And when we simplify all of this here, we're going to get what? 18 minus 9 is 9. We're almost there. So now we're just going to divide the whole thing by 9, which is going to give us x minus 2 squared over 1 squared minus y plus 3 over 9, which is the same as 3 squared. And then 9 over 9 is just 1. And we now have our standard form. So our centre is going to be 2, negative 3. If you can't see why, those numbers come from here and here, and you just have to remember to opposite the signs. And then the vertex, you might need a little sketch to help you out here, so let's just draw a little sketch. Now, first of all, you'll notice that the x term comes first, and when I taught this in class, I said this is going to be orientated like that. Okay, it kind of looks like an x, doesn't it? So let's put our center on there. So 2, negative 3 would put me here. There's my center. And then we go a distance of 1 in the x. So we go 1 in the x each way. We're going to go a distance of 3 in the y. So 1, 2, 3 here. And 1, 2, 3 here, and with hyperbolas we make this kind of rectangle, something like that, and then we draw the lines through the diagonals. I would do this slower and in more detail if I hadn't already shown you this, but this should be just a review. And from here that forms the asymptotes that we use to draw our shape. So it's going to be something like that.